Here we have our lightsaber. You'll note it's growing with adequate brightness, which we can adjust right here because it's kind of bright to see. So what we're going to do is take one of these little convenient, well, wait a minute, hold on. Alright, our current meter, okay, I know you guys are going to say get a better meter, but you know what? Screw you guys. We're running 14 milliamps. It's the same. Okay, we're at our lightsaber circuit here. It's the exact same one that I've been using for everything. And it's good success. This here is at partial brightness. And we can adjust that simply by decreasing the resistance. See, we went up to just under 20 milliamps. Adding that resistor to it, you know, decreasing the resistance to about 50. Sorry about the loose connections, but come on. I'll tell you what, let's do this right here. Add this resistor. Add that resistor. Take that one out of the equation. Okay. There. Now we're running at 6 milliamps, 7 milliamps, 7 milliamps. Now the brightness did decrease substantially. Well, about 50%. See, we touch that back to it, our brightness gets real bright, and it's at 20. By varying the resistance, this resistance right here, we can change the output of the brightness. I found that putting a 1 mega ohm resistor in series with a 47K resistor works the best. This right here diode is just any 1N4 whatever, as long as it's, well, they don't make one small enough to burn up. So there's only 12 volts tied to this circuit here. Alright, we have a capacitor here. This capacitor serves an interesting function because the back feed from this coil right here, see, there's our coil. And what we have here, if you look closely, you'll see that we have 6 wires coming off this coil. One, 2, 3, 4, 5, 6. We have 6 wires. 1, 2, 3, 4, 5, and 6. Wait a minute. Let me show you. 1, 2, 3, 4, 4. Here's one and here's one. Alright, so we have 6 wires. That's a primary. Let me show you in this toroid model here. So you can make it with a toroid as well. The capacity of the ferrite material is such that it doesn't allow for any it doesn't allow for that much storage of energy in the core material as the ferrite bar right here does. It has a more mass equals more storage capacity. And what we're doing is we're taking the energy through 2 coils, and if you look at the print, you'll see that it comes in goes to this transistor right here. One side's hooked to positive, one we hook the collector right here through a coil to the ground. Okay, next we're going to take the opposite legs of this coil, the opposite direction. We're going to hook one side to the base and one side to this resistor right here. As well as we're going to take a diode and hook it from the base to power. But it's hooked up to where the cathode and the plus are together, so energy can feed into this circuit, but it can't feed back through. And what happens here, as it charges this coil up, which it's going to inherently do by default, this here has that coil at negative, and with the PNP transistor, negative actually turns it on. So as it charges the coil up, it's also, these are wound right together. It's two strands of wire wound around the coil. And we're gonna go this way. I always try to go clockwise when I wind coils, everything. So but there's two strands of wire. Now I can tell you one thing, inherently by its nature, if you look at the lights, it just inherently wants to pick up stray frequencies, just because. And I don't know that it's frequent. I can't hook a scope to it. I don't own a scope. If anyone wants to send me one, I'll take it. Then I'll send you nice pretty pictures of the more energy you store in this core, the more power you have for use. And that is basically how it operates. There's a core. It could be any kind of core. This is wound with number 36 wire all the way around the entire thing. And over the top, I take I took 28 gauge wire. Yeah, 28 gauge wire, and wound 12 dual coils all the way around it. It could probably be more. It'd probably help if it had a few more. I usually limit myself just by how much space is left in the middle to run wires through, and it'll work either way, but it tends to work better at lower current the higher the coil count on the primary. Output suffers a little bit, but that's such a judgmental thing. Does it matter if you have 20 volts on the output, or, and I mean, that's all stuff that could be tuned through the hooking up of the lighting. Now let's get to that real quick. What I have here is a bank. I'm going to hook the power for a minute so I can show you. Okay. See, watch, we're going to unhook it, and then it takes a minute for it to go out, even with that little 220 cap. And you can actually tune this down to next to nothing just by changing this one resistor right here. And I have it laying here somewhere. Let's try this one, see if it works. Alright, all I'm going to do is hook it up here, and we'll turn this puppy on. Alright, then still have this resistor in here. It's a 100K. I'm going to take it out though. As you see, the lights are still burning. Our current draw is currently at 2 milliamps. I will note that you can take and run actually, 90, 100 LEDs hooked up in banks of, say, in this case it's 10 works out. Could be 9 with the ferrite. With these cords, I found it usually about 4 or 5, maybe, because them white LEDs use more electricity. They're about 3.3 volts a piece. So you add 10 of them together, that's like 36 volts. But we're driving our 36 volts from the collapse